Okay. So one of the learning targets said something about solving differential equations. Okay. A differential equation is basically an equation where the derivative is already been done for us. We need to solve it, or we need to do the antiderivative in order to solve the equation in a sense. All right. So in that instance, if you were going to do an antiderivative, you can't get a specific answer because all antiderivatives have this plus c in them, plus some constant. You don't know what that constant is, so there's not really a way to solve it. You have to be given at least an initial condition, or in other words, like an initial coordinate, in order to be able to solve it for c. Okay? So that's kind of what we're doing here right now, is we're going to solve a differential equation by me giving you what the derivative is, and then therefore you need to find the antiderivative, plus I'm giving you an actual value so you can solve for c. So you're solving the differential equation in a sense. Alright? And that explanation is not great. We'll do an example here. Alright? I will go ahead and say that f prime of x equals 1 over x squared. And we're going to assume all x values are greater than 0. And you're going to find a solution such that f of 1 equals 0.
Is this still C18?
Yes, I believe it should still fall on the C18. Okay. So, thoughts? What did I give you?
So,
Well, this is the derivative of f, capital F, right?
so what we could probably do is do it the same way as we did yesterday, then put in the plus c, change the x to 1, and change the f that we found to 0, solve for c.
Yep. So by what we did last week, he's meaning what are we going to do? You're going to do the antiderivative of the function. Okay. Integral. Antiderivative. Okay.
Maybe if you would, that's what this class is about.
We have to write that every time, the integral thing.
So we're going to do the antiderivative of 1 over x squared.
When we write it out like that, can we just start by changing it into the form that we like, as in changing it to x to the negative second, or would you like us to put it as the original? Does it not matter?
I would be fine with that. So he's already changing it. This would be x to the negative 2. So what is the antiderivative of x to the negative 2 power?
Negative x to the negative first power?
Right? Thinking it's negative x to the negative 1. Would that work?
Negative 1.
Try the derivative. Negative 1 times negative 1 would be positive 1. And then you'd have x to the 1 less power. So it would be x to the negative 2. So 1x to the negative 2, which is what we had, right? Plus c.
And then we'll just change that to 2.
Could you not just X to the negative one?
X to the negative 1? Negative x to the negative 1. It's got to be negative. Because if you had x to the negative 1 and you did the derivative of
Wait,
that,
wouldn't it be to the negative?
Oh,
wait.
never
if
mind.
if some function was x to the negative 1,
It'd be
then
negative.
g prime of x would be negative 1 x to the negative 2.
I see. Yep.
And we don't want negative 1 x to the negative 2, we want positive 1 x to the negative 2. So
I
that's why
see
we
it,
got
thank
the
you.
negative there. Yes, Carter?
No, never mind.
Okay.
So then
Okay.
we just
So
put
then
in-
this is the indefinite integral of this function. This could represent a whole family of functions. differing by some c value. If they don't give you this right here, there would be no way for you to figure out what that c value is. Okay? Remember, this is essentially our f,
So
right?
f of x.
F of x was equal to the antiderivative of the derivative. So f of x is equal to this.
So it should be x of, or f of 1, which equals 0. Put a 0 there, put a 1 for the x.
Yes. Go ahead and do it. So, therefore, if you put a 1 in for x, we should get 0 for y. This is like our y value. So 0 equals negative 1, or the opposite of 1 to the negative 1 power plus c. So when I plug in a 1 for my x, I know I'm going to get 0 for my output. One to the negative 1 power is still 1. The opposite of that would be negative 1. Add 1 to both sides. You get c equals 1. So then you can write your final answer. F of x equals negative x to the negative 1 plus c, or if you prefer, negative 1 over x plus 1. So I don't want to leave negative exponents in my answer, so move that down to the bottom. So you just solved a differential equation. You took the differentiated equation, you took the derivative equation, and you found the original equation. But in order to find that, I had to give you an initial set of conditions, because without that, there was no way to solve for c. Because just doing the antiderivative gives you a whole family of functions where they're all plus c. So plus 2, plus 3, plus 5, plus 10, who knows?
Plus 6.
Okay?
Plus.
Questions on this?
No, not plus 6.
Okay. Let's look at the physics one about solving a vertical motion problem on page 254.
Example 8, or?
Yep. So, ball is thrown,
Thank you. Shut up.
They'll give you all those.
initial vertical velocity is 64 feet per second. Initial height is 80 feet. Now, enough of you have probably taken a physics course or done enough with science that you could probably write the position function already, okay? Because you know what the position function of projectile motion is, all right? But I'm going to show you, basically using antiderivatives, how that comes to be, all right?
That's where it's at.
We know that the acceleration due to gravity on this planet, okay, and when we're working with feet, negative 32 feet per second squared, right? Okay? So we could say that the second derivative of the position function is negative 32. Because we know the second derivative is acceleration. So if we know the second derivative is negative 32, we're going to kind of do this in our heads here a little bit. The first derivative, so let's mentally take the antiderivative of negative 32, what would you get?
Negative 32t? No, or
Plus c,
plus c.
okay? Negative 32t plus c. What I did was I did the antiderivative of negative 32 with respect to t.
What's half of 32?
But let's actually figure out what c is. We can figure out what c is because you were given
The
some
velocity.
information right here.
The velocity.
The velocity was 64 at the very moment the ball was thrown. So really, this is like telling you that s prime of 0 equals 64. S prime represents our velocity function. Our velocity when time is 0 is 64 feet per second. So I know that if I plug in a 0 for t into my velocity function, I should get an answer of 64. So in that case, the answer here needs to be 64 when my time is 0. So therefore then c, in this instance, is 64. So therefore my velocity function is negative 32t plus 64. That would represent my velocity function.
That's why there's the half on the function.
So we know this is the acceleration due to gravity in feet per second squared. This would be the velocity with respect to time for this instance. Now if I want to go all the way back and find my position function, or some of you would think of it as the height function in a sense. So I need to do one more antiderivative of this. Okay? So s prime of t is this. So s of t then. What would the antiderivative of negative 32t equal?
It would have to be t squared, which means half
T
of
is
32,
16.
which is negative
Negative
16.
16t squared.
Wow, okay.
Antiderivative of 64.
64t.
64t. Plus c.
Which we already know the initial height is 80.
Very good. We know that s sub 0 is 80. So there's your initial condition. We know that when the time unit is 0, the height or the position of that ball was already at 80 feet. That was the initial height. So in a sense, whoops, I know that if I plug in 0 for t, I'll get 80 for my height. So 80 equals negative 16 times 0 squared plus 64 times 0 plus c. So 80 equals c. So the position function would be negative 16t squared plus 64t plus 80. That would represent the position of that ball.
Why do we need to do all that?
Okay.
Already did this.
Well, basically what I'm showing you is how antiderivatives work in physics. Showing you also why what you know as negative 16t squared plus initial velocity times t plus initial height, that's always the rule.
Yeah.
Basically showing you how that works or why it works in a sense. Yeah, absolutely. That's all I'm doing right here. I'm not saying you have to do the problem this way because, yeah, if you guys know physics enough, you know that a projectile that's being launched on this planet in feet will follow the formula negative 16t squared plus initial velocity t plus initial height all the time. But we got to that all the way from the acceleration due to gravity. Does that make sense?
Yeah.
Okay.
And if we had a different acceleration, then that's why it's half.
Yep. To answer the question, when does the ball hit the ground? Okay. This is kind of an algebra 2 one, but when does ball hit the ground?
When s equals 0, or f of s of x equals 0. Or s of t, sorry.
64.
Yeah.
what I have to do,
Find the zeros.
find the zeros, so in other words, algebraically, put what in first though?
Negative b.
Put a 0 right here,
Oh, yeah.
okay? This factoring is actually not that bad because what can you do?
Take out a.
Divide everything. I divide everything by negative 16. That way you get it to be a positive t squared. So 0 divided by negative 16 is still 0. This divided by negative 16 would be t squared. This divided by negative 16 would be
Negative 4t.
negative 4t. And 80 divided by negative 16 would be negative 5.
So.
What multiplies to negative 5 and adds to negative 4?
Wait.
Negative
Negative 5.
Negative 5 and positive 1.
That's my boy, right?
So it'll be 1 second? Or no. 5 seconds, because.
Set both factors equal to 0. So t would equal 5. T would equal negative 1.
Negative 1 doesn't apply here, so just the 5.
So 5 seconds to hit the ground. Okay? That one's not as much related to antiderivatives, but I showed you how to get that equation using antiderivatives from the acceleration function, and then we use that to answer our question. Okay? Alright, I'll put the assignment up there and then I'll address any questions you may have had on some of the tougher derivatives. Page 255, 27 to 34, 39, 41, 42, 57 to 64, 71 to 70. Yep, there's a bunch of them.
But we're thankful.
Yes.
So what's the real assignment?
We are blessed.
Okay,
I appreciate you.